In part 2 of lecture 3, we're just going to be practicing, mostly you're going to be practicing, and then checking to see if you're getting it. These reactants in a double replacement where we have a compound reacting with a compound. First, you would come up with the products, and then you're going to look at your solubility rules, your common gas chart, formation of water. Try to decide if any of those things formed that indicate definitely a reaction occurred. Let's look at this first one. We have our AB plus CD. We know we're going to get AD plus CB. So we've got trading of places here with replacement. We're going to have NaNO3 plus AgCl. And in this case, everything's already balanced, but if you needed to balance by putting 2s or 3s or whatever in front, make sure you do that also. We're always starting with 2 aqueous solutions, and now we're going to look, definitely there's no water here. I don't recognize any of the reactants from the common gas chart. So for this one, I would want to focus on the solubility rules. I can see from rule 1 that this first compound is aqueous because it's got a group 1 element. And then on this second one, it's got chlorine. So I believe I'm going to look at the third rule in the solubility rules. And most of those are going to be soluble, which is AQ, unless paired with, and then silver is the first thing mentioned. So this one is actually going to be a solid, and I know that yes, this reaction occurs. Here's another reaction. We've got 2 aqueous solutions, and I'm going to let you go ahead and pause the lecture. You're going to do the double replacement reaction, evaluate each of the formulas you have as products, and decide, does this reaction really take place or not? So pause the lecture and then turn it back on to see how you did. Hopefully you got what I got. It doesn't matter whether you listed the strontium phosphate first or the potassium nitrate first. Those can be in reverse order. They don't have to be listed exactly like that, but that's everything you should have on the product side. What we really want to focus on is those states of matter for the products. Because strontium phosphate has phosphate, and then phosphate's not mentioned anywhere in the solubility rules, that would be rule number 6 applies. Assume all other things are insoluble, which is a solid. And then the potassium nitrate, potassium's a group 1 element, rule number 1, and actually rule number 2 with nitrate, and that's why it's aqueous. So this reaction does occur and it makes a precipitate. Go ahead now and try this one. Pause the lecture to come up with the 2 product formulas. Use the charts to decide if this is actually a reaction that occurs, and then turn the lecture back on to see how you did. You can see on this one, I got barium chlorate, and I got silver acetate, and I decided both of those were aqueous. So I would actually, on a test, either cross that out if I showed all of that, or if I haven't shown anything, put the NR. So you're either going to cross it out and put NR, or you can literally just go right to NR. You don't even need to show me what the product. So if you did it on scratch paper and you decide this is not a reaction that occurs, you can just go back on the test and put NR. Go ahead and try this one. Pause the lecture and then evaluate. Turn it back on to see how you did. Hopefully you recognized with this one that you had an acid with a hydroxide compound. So that's that formation of water that we see up here, the formation of water. Okay, make sure this. And there's our water as a liquid. So yes, this one definitely reacts. Try this one. Pause the lecture, come up with your products, look at all the different charts and things, and decide if it actually occurs. This is what I got. Notice I am using the HOH, but you could list this as H2O. Either one is acceptable. I like the HOH because it makes it very obvious from my double replacement. The AB plus CD gives AD plus CB. Water is formed, the reaction definitely occurs. All right, two different reactants here. Remember, everything is aqueous. Pause the lecture and see what you get as the products. Compare it to all the charts and decide, does this reaction really take place? Welcome back. I noticed that this one was made with an ionic compound that has sulfide, and it was reacting with an acid. So I knew that I was going to get the gas. If you didn't know that and you just did the A, B, C, D, you still should come up with H2S, and then your eyes need to go to the chart knowing this is going to be a gas, it's not the hydrosulfuric acid, and you're going to say, yes, the reaction occurs. All right, we are getting close to the end, not quite there. Go ahead and try this one, see what you get for your products, and then turn it back on to see how you did. This one shows a carbonate reacting with an acid, so that's up here in the common gas chart. I know I'm going to get carbon dioxide gas. That being said, maybe you did the double replacement and you got the H2CO3, and then you got the KNO3, two of those. But you've got to remember, when you see H2CO3, you've got to break it down to give the CO2 and the water. It's always going to do that. This is your last one. I hope that you are really feeling your efforts are paying off here. So hang in there. It's the last one. Come up with your two products. Look at all your charts and decide if this reaction truly occurs. All right, did you notice that you had the ammonium compound with hydroxide reacting with hydroxide, and that gave us the NH3 gas, water, and the aqueous ionic compound. But again, if you had gone right to your double replacement, you were getting NH4OH plus NaCl. And now you know that similar to the H2CO3, this is always going to break up and give us the NH3 gas and water. So make sure that you remember those. That's it for this one. I know it's a lot to take in. You'll have time to practice this. Thank you for hanging in there.